Pumped up. Okay, there we go. Started recording now. Apologize to anybody who's watching this video later on. All we did was talk about the first two first couple slides, and basically what the motive is for the Hooks API. So didn't miss much. Now we're talking about classes and the introduction and proposal of classes into JavaScript. So ECMAScript, which is the actual basis for the JavaScript language, has different versions, and the first version was created in 1996. I actually remember being excited about the beta version of Netscape Navigator being released because it was going to have JavaScript. And up until then, I'd only done HTML and CSS on my GeoCities websites. I don't know if anyone here has ever heard of GeoCities or Angel Fire, I think is another one. Zombie in the ES Grave is punching out of the ground in ES4. Exactly. So here, that's the story, is that in 2003, there was a lot of arguing going on about what JavaScript should be. And so all the people involved on they call it the TC39, which is it's a committee for proposals to JavaScript. They were trying to figure out what ECMAScript 4 was going to look like. And one of the ideas was we should put classes into ECMAScript because Java has classes and other things like that have classes. So we should have a familiar syntax in JavaScript or ECMAScript, which ultimately is JavaScript in the browser. We should have that interface. Okay. Well, ECMAScript died. Or ECMAScript 4 was never released. ECMAScript 4 got killed by that conflict, by the people arguing and not deciding what would happen with it. And so really classes only really got introduced into ECMAScript in 2016 ultimately. And that's why we say ES6 classes. So so classes are not new. They are actually reborn from the grave 13 years later, making a comeback. Does that make sense to people where that history is? Okay. So we need to think a little bit about if classes only came around in 2016 and React was created in 2013. Okay, so that's a 3-year gap. How did people make components for 3 years in React without ES6 classes? And that's under a situation where browsers support ES6 classes from day one of specification release, which is not going to happen. So we're actually talking more like 4 or 5 years, let's say, till there's support across all the browsers for these classes. There's two things we can do in this situation. And the first thing was, don't even think about classes and use what we have in JavaScript to build components in a way that React can understand them. And so that's what the React team did. Don't read this right now. I'll explain the different highlighted pieces in a minute. But I also want to kind of say that even if we don't have classes supported in the browser in ES6, as soon as a tool like Babel comes along, which is a transpiler, we can write ES6 code, transpile it to ES5, and then run it in the browser. And so that's kind of that's what happened. Is first what the React team did was they created this React.create class library. Hold on, I just want to see if I can. There we go. That's interesting. Okay, I'll have to figure that out. I was just thinking about the recording for a second, but I think it's reversed on my screen here, which is, yeah, figure about that. Okay, so React provides this API called create class. They don't anymore, but they did. And I think it was maybe version, I put it in the notes 15.5 that they removed this create class. And you can still do it if you want, but you have to actually require another library called react-create-class. So no one does it. Doesn't matter. Point is, I could create a class before using this syntax and pass an object that had all of the different functions that I wanted on my component. And the only one that's really necessary is the render function itself. Because if a component, so originally when a component just needed to have a render function, and this is what would be displayed for that component. And if you needed more behavior, for example, you need an initial state, well, then you could define that initial state here. You still have to declare a function, and it will return the initial state. When we want to access props, we have to use this context because within this function, we want to access the props of this class that was created that's in the instance of this object. And now I'm getting out of hand. So let's just look at this and say it was like this. This is how people created classes in JavaScript before ES6 came along. Um, it this is the equivalent without React. This is what you would do if you wanted to create an instance of an object in JavaScript before ES6 classes. Has anyone not seen code like this? The main thing I want to point out is that I'm calling new on a function. That's the main difference here. Instead of just calling the function, I put the new keyword before it, which creates an instance of this object that's created here. And I pass in two values, 0 and 0, and they come in here as x and y. And then I assign them x and y to this dot x and this dot y. And I do that because I've created an instance and I want these variables to stay within that instance. So I make them instance variables by applying this before it. So this is a special keyword that means, well, it actually doesn't mean, and that's why it's confusing. I wish it meant within this object, but it means within this object under certain circumstances. And we'll get into more of that later and why we have to deal with that. But for now, in the constructor at least, and that's what we'll call any function that's designed to be a function object constructor like this, that's designed to be called with the new keyword. We'll call this the, let's say, function constructor. Within there, this is always going to point to the instance that you're creating. Okay. And then how do I add functions to this? Well, I can add them on the prototype itself. And this is called prototypal inheritance. May have covered a little bit of this before. We don't get too deep into it. Again, a lot of the stuff we're doing doesn't require deep knowledge of this. So it's something that needs to be done a bit more independently. But here we've added a function to this function object, not to the instance, although the instance will have access to this function, which means when I create the instance cursor here and I call the dot position function, what I'll get returned is the values of this x and this y from that instance. Does that all make sense? Is there any confusion around this code before I move on? All right, thank you. And so ES6 class syntax to perform the same goal, or the same code on the last two lines there, and the definition of that class is the different part, but very similar. So we've defined a constructor specifically within a class like this. The function that's on the class here, this is going to be a function that can be called on the instance of the class. We won't get into static functions right now, maybe some of those other things. It's not, again, you got to learn a little bit at a time. So let's only focus on the things we actually have to learn right now to use ES6 classes with React. And that would mean pretty much for our examples, you need to be able to create instance methods on your classes. So anything you want to handle a special a button click, but you want to put that into its own function, you would create an instance method on that class, and that's where you would do that logic. Okay. Make sense? Any questions? Okay. So this is what something like the same kind of thing could look like as a React component that uses a class. So here, there's a few differences. One, we actually import the named component export from the React library. And this is a base component class. Excuse me 1 second. So this is a base component class, and it provides a lot of that core functionality that all components need. And so things like this dot props first exists on this component here. And then when the data is passed in to the component, it creates the props object just like we did back here when we create our X and Y. Well, the base class is going to take care of that when the prop is passed in. And how do we pass props to this component? I want to actually get an answer from someone for that on that. How someone could even type in the message window. If I were to use this component in React, how would I pass the X and Y props to it? I'd like to see that in the chat, please. Yeah, exactly. Yeah. So Rishabh got it right. Um, you create a new React element called point, and you give it two props x and y. And so that's how we could just. It's the same as any other component at that level. React doesn't. We don't treat them any differently. It's only the implementation and what it looks like at the end. So, okay, that's great. I think also I want to just point out that the non-JSX equivalent, and I'm just going to put that in the chat as well, just so we have a record of that. So if I don't have JSX, then I would do it like this. And that's all that JSX gets converted into, right? So when our pipeline takes this code, takes the JSX, or the JSX that Rishabh put forward, that gets converted into React create element where those two values. So then we can think about, what does React do with this stuff that we give it? It goes and it creates this instance for us. It must call new somewhere, right? React must call new somewhere to create an instance of this point component, and then it passes in those props to it. Does that make sense? It must happen that way, because I don't call new on a point anywhere in my code, but that's how we create instances. And so React is storing that instance of that component for you, right? As long as it's needed, in the DOM, that component will stay in memory, and React is going to manage that component in memory for us. That's kind of an important thing to think about. So let's not jump ahead too quickly. If anyone has a question, or if anyone's confused by that, maybe just put their hand up or something. If everyone's good, then I'm very happy with that. But think about, how does React actually treat your component, and kind of what is it doing as we're interacting with the user interface? We don't need to know the details, but in this case, an instance will be created of the class, and for the lifetime of that instance, React is going to manage that instance for us. So it'll call new, and eventually it'll decide when it's not needed anymore. Okay. Well, this is a really bad example, right? Because why would we ever write a component like this, especially even when we had even when we didn't have hooks? Because at the end of the day, we've always had function-based components in React. It's never been the case that you couldn't create a React component as a function, or at least, sorry, I don't know if it's never been the case, because I actually haven't been using React since 2013. But I would say for as long as I've been using React, so over 4 years, it is. I've always been able to create a function and use that as a component instead. This is what you should do. Even in class-based React, this is what we should do. There's no point in creating a class if we're not using the features that we have to that we need classes for. So the React component class that we extend comes with an instance method called create element. So thank you for asking that question. That's not correct, because we don't call. We don't have access to that instance necessarily. React has a create element component. So if we wanted to, I could add create element as an export. This is where create element would come from. And I could then call react.createElement here instead of using JSX. But no, the React components do not have a create element instance unless you were to actually add one for something completely different. Because React only assumes that there are a few different methods on there. So we actually have a good list of what methods are available, and I can tell you, create element comes from the React library itself. So the reason why, actually, this is actually a really interesting thing, and I hope maybe this clears some things up for people as to why, if I leave this out right now, if I leave out React, we have an issue, because this is not going to build. We can maybe go and see. Save that. React must be in scope when using JSX. So that's the warning I'm getting. And what that means is that somewhere we're trying to use React in this file. And that's right here. But we just don't see it. But if I were to write this out after it's gone through the JavaScript transpiler, what we really end up with is something like this. And it has children, and that child is also created as a React.createElement call. And the child is an LI, right? So this is how it's actually working. So that's why we need to make sure that at the top of our file we include, that we actually include, oops, let's go. Actually, no, I've committed, so it doesn't even matter. Where are we? Boop. Okay. Oh. All right, let's get back to it. So yeah, so where were we at? The React class that we extend comes with an instance method called createElement. Note, we import that from React, but we don't normally import it because the JSX conversion does all that for us, and then it just calls React.createElement that way. So if we're creating pure components, and a pure component is anyone that takes in props and returns the exact same elements, no matter what when those props are the same, the elements it returns are the same. So there's no internal state that could change what this renders. Does that make sense? The purity aspect of this. So if I have a pure component, just write it as a function, obviously. Then if I have a stateful component, I have to now use this other syntax with classes, let's say, because I don't have hooks yet. This is how I could declare a default or initial state in my ES6 class and then render that state out in the render call. Okay? So this is using a class property, which technically is not part of JavaScript yet, but we use transpiling to use the feature ahead of time before it's ready in the browsers. So this just gets converted into something that the browsers actually understand. But we're using even some class syntax that's still being added into the language that hasn't been fully supported yet. So that's what you might see. You might see older examples here that look like this instead, where we have a constructor, and in the constructor we set the initial state. Well, we don't really need to do this anymore because with that change to the JavaScript specification that we're starting to use, we can use these properties instead. And that's just a little bit of a cleaner way to do it. Because one of the things we have to remember is if we do use a constructor in our component, we must pass props down to the component class using the super method. So what happens here, when React instantiates or creates a new instance of the counter component, it passes in props. Those props come in here to the constructor. The constructor takes those props and it passes them to the super class. Can someone type in the chat message which one's the super class in this context? Or just say it. You can unmute and say it too. I'm totally happy with either. Yeah. Component, exactly. Because we've extended the component, then this constructor super call will reach the component and actually just call the constructor of the component because it also needs those props. And if we don't have a constructor, then the only constructor that gets called is the one that actually is inherited from the component base class. Okay, I'm using lots of these terms, these new things, maybe new, maybe not. We don't use this much anymore. I consider constructors to be legacy more so now because of this change that we have, the ability to do this. Okay, so when we want to change state, we have to introduce another function. This is actually, so Rishav, when you asked if createElement was an instance method on a component, that's not the case, but setState is. SetState is created on the component class provided by React. So within any component that we extend the component class with, so our counter, for example, we have access to this.setState, and then we can set new key value pairs here. So we're replacing the value of count with the value of this.state.count plus 1. Okay? And that's every time we click on this button called increment. And we've passed it into an anonymous function here. because we don't want to call this dot set state immediately. We want to call it when the button's clicked. So we wrap it in an anonymous function and pass it that behavior to execute when it clicks. Make sense? Okay. Again, we're going to do live coding on this. I just want to show examples. Okay. So event handling or handling the events. This is where it starts to get a bit interesting and where classes start to confuse people because we're using this context to access the state. And what I've done here is instead of creating an anonymous function, remember, I created an anonymous function here, but instead of creating an anonymous function, I created an instance method called increment that could contain 2, 3, 4, 5, 6, whatever lines of code in it, lines of logic, including this dot set state to some new value. Are we wearing the same shirt? Are we wearing the same shirt? It's pretty close. Yeah, I think Avery and I wear a pretty close shirt. Is it? Oh, you got mountains, I got trees. I got trees, you got mountains. Okay, cool. Is it 10 tree? Okay. Okay, yeah, cool. Okay. All right. Sorry, I got distracted when I was like, wait a second. All right. So what I was saying though is that I've moved this now. I've moved this logic into this other function that's an instance method on my class. And now I'm just passing the reference to that function like I did with the anonymous function, except it's named here. This code does not work as expected. And it's because when this function gets called, the context of this is set to something that's not this class. And so we get cannot call set state on undefined as an error, something like that. So the way that we solve that problem is by binding our this context to the component in a way that we can predictably have this context be correct. Okay, and this is one of the things again that we spent with the previous curriculum when we were teaching React in classes. This was one of the things that every student said, "I don't get it. I don't get it. I don't get it." And then eventually people got it and moved on and didn't care so much anymore. Right. So it's okay. Let's just start to learn some rules around it and how to deal with the problem, and then we'll start to understand the problem over time and have the solutions already available to us. So I made a real quick change here. I know that state's moving, but I'm going to say, as I move this back and forth, what's the difference here? This is the original. Look at that increment function. Make it an arrow function. That increment function here is very similar to any of your function declarations in JavaScript. So this context is actually bound when it is run, which is different than how arrow functions behave, where this context is set based on the context, or based on where it was declared in the first place. Okay. So there's actually this yeah. Oh yes, thank you, thank you. Arrow function won't have this context. So arrow functions will inherit this context from the scope they were declared in, which is slightly different. I mean, yes, if you need to use this context, then don't use an arrow function. But if you need to basically not have this context rebound, one of the ways we can do that is with an arrow function. And that's also why, if we look at this example back here, it works just fine because when we create this arrow function inside of the render method, the value of this is the value of this for the render method, which is the class. That's the value in the render. Nothing calls the render method except React through the class as an instance method. So that means that this inside of the render is always going to be the counter instance, which means that when we use an arrow function here, it'll just continue to use that this value because the arrow function makes it not declare its own when it's run. Okay, that's the difference here. If I used function syntax where I did function with curly braces around it, this breaks again because that actually sets this context in a similar way to this type of function here, which is our instance method, right? I know this is getting confusing. I just want to introduce some of these things so that as we go through the actual code examples, I can show you 2 or 3 ways to deal with it. And then here we've just said, instead, we'll use the same kind of assign a class property and make it an arrow function. And therefore, our this context is now set so we can access the set state function. and we can get the previous state so we can add one to it. Okay, so there are many ways to bind this context, and I've put the note in the notes here. Oh, why is it there isn't an arrow function? Thanks for the reminder. I really appreciate it. I want to be better at this. It's just I could probably. That's just going to keep disappearing though if I do that. I think. Okay. Why is it there when there isn't an arrow function in the event handler? Then the function you pass in gets called to me. Oh, okay, that's a good question. So let's go back to some code. This is all kind of. I'll just create a new file here. This I think is the sort of simplest version of this question. And if I put a console log in here, okay. So here, if I do an on click and I want this function to be called when this element actually gets clicked on, which is different than calling it when we pass the function to it. So I could say, actually, I want to pass. Usually this only happens. The reason why I'm adding an argument here is usually this only becomes confusing when we actually need to pass in an argument. Because normally what we could do is just pass in the reference directly. So normally we pass the reference directly, no problem. But when we want to actually call this with a value, then now what we're actually doing is invoking the function. And if we invoke the function here, that happens when this function is called, not when the onClick happens. And then when we call this function immediately and we return, well, this function returns undefined because it doesn't return anything explicitly. That means that what we're actually assigning to onClick is the return value of the do something function, which is undefined. So we may as well have just done this in our code. And that's not going to work because if I do an onClick now, then it's just going to not fire, right? But this is where it starts to get a little bit weird because if I do a set state and it changes the state, and then I do this here, well, now I'm going to call do something. It's going to call set state. It's going to re-render the component, which is going to call do something, which is going to call set state, which is going to re-render the component. And this is where we get our infinite loops from. That we know this gets called when the render occurs, because if it didn't, it wouldn't loop infinitely. If we do this instead, we prevent this to getting called only on that one button click instead. It causes a state change, but then when this re-renders, it calls. It doesn't call a function. It just passes the reference to the function to the onClick handler. Rishabh, can you let me know if that's in a good direction in terms of your understanding, or if there's more that's needed? Exactly. Yeah, and this is this is a reference to a function, and this is the invocation of that function. So exactly, that's why it happens, and it just matters when does this code get executed. So I think I'm glad. Thank you for the question, because knowing that is obviously going to make um, finding those bugs easier, right? And I still make that mistake, and I know how to fix it in 30 seconds because I see the infinite loop in my output, and then I think, oh, wait a second, maybe I should go look at where this function is being called, and then I go and look in the render and see, oh, I didn't wrap it properly or something, right? It's a common problem. So thanks for calling it out. Okay, let's say any other questions before we move on. So this is just event handling in this context. We have 5 different ways to handle it. Lots of different ways here. I'm not going to go through each of them right now, but I will show you a few different ways when we're writing our own components. And I'm also glad they moved this off Medium, and everything from Freed Code Camp has been moved off Medium. Congratulations, Freed Code Camp, on freeing yourself from Medium. Yeah, there you go. I hate Medium. Okay. Component lifecycle. This is now a bit more relevant to us. Has anyone not heard of component lifecycle yet? I see a slightly shaking hand. That means that someone that you've heard the word before in this context, most likely. In the context of React, you've heard of life cycle. Maybe in the context of components, you've heard of life cycle. It is my so I am very, very careful when I teach React about not trying to make life cycle and use effect in any way the same. It's very important to me, and this is a disclaimer. It's very important to me that right now we don't think about use effect at all, and we only think about class-based API and how they handle side effects, and we don't take what we learn now into our use effect hook. Because so you were all untainted by the class-based lifecycle approach to React, and so it's actually quite a nice situation to be in. I know seems like a lot of work, but it doesn't matter if it's classes or hooks. You're going to spend a lot of time learning React. So by learning hooks first, you don't actually have to. You didn't have to throw out a lot of the behavior that should not be transferred in from classes to hooks. But we still have to learn them. So this is the disclaimer that says, do not make them the same ever, and don't let anyone tell you they're the same, because they're not the same at all. Okay, that's the disclaimer. I know it sounds pretty heavy-handed, but it's too hard to learn use effect as it is, and if we add in bad mental models, then it's even worse. Okay. So we've heard of mounting, and I know that when there was a question, I think it was yesterday's lecture, about mounting and unmounting and kind of how that works, or the day before, actually. It was the day before. Uh, and so this is where we're going to talk a little bit about mounting and unmounting. And in order to talk about mounting and unmounting, we need to know where things are being mounted and unmounted to. So does anyone know where our components are being mounted and unmounted? And again, when I say mounting and unmounting, that is a component consideration, not a class-based component consideration. It's a all components are mounted and unmounted. It's just we care a lot less about mounting and unmounting when we're dealing with hooks, whereas we cared a lot. We specifically leaked that abstraction of mounting and unmounting into our class components. So therefore, that's why we talked a lot about it before, whereas I don't talk much about it anymore. It's not the way I think about this stuff anymore. So this concept of mounting is applied to all components. So where do we think in React mounted to the React DOM? That's a great one. Yeah. So it's some sort of a DOM. It's the React DOM. We'll call it the virtual DOM. That's another term for it, because React keeps track of this version of it's a representation of something that could become the DOM, essentially, right? Or and then they convert it into a virtual DOM so that they can compare it really quickly and figure out what's changed, and then do the updates in the real DOM and really limit the number of updates that are needed for that if possible. So yes, things are mounted and unmounted into the virtual DOM. And so when that happens, we want, and then ultimately the DOM. So there are basically three stages or three phases of a component. And the first one would be that it is mounted, and that is if it's a class, I'd say that is the instantiation of it. That's when they call new on it. That's when that's happening, essentially. Okay. Now there's a whole bit of time in there. So it's the constructor is called first. That's the instantiation. React says somewhere they say new mounting example, and then they pass in the props and they get back an instance. So that's the first method in the component's life cycle that will be called as the constructor. We don't do a lot in the constructor. You probably will not need to use the constructor. So most of the time, the first method that will be called will actually be the component did mount, or so actually the render call. So I'm going to bring up this. Actually, I'm going to show you how to do it. React component life cycle, and I don't even need to type it properly. And I'm looking for images here. There are lots of different diagrams. Right? Lots of diagrams of the component life cycle. If you actually go to my old React lecture, I've got, and if anyone's curious about this, we rebuilt Tweeter using React and class-based components, so it could be an okay review as well, if you're interested. But this is kind of out of date now. That's why I don't teach it much anymore. And if we go down, that's what it looks like, the Tweeter. And here is my own diagram of a component lifecycle with mounting, updating, and unmounting described. So lots of different options out there. I'll use this one because you have access to it, and it's easy to find with Google. And I'm not even going to include it in the notes because I want you to find it and start searching for it if you ever need to. Let's see. Oh, come on. There we go. All right. So this one here, go find it, use it if you need a reminder. It's kind of cool up here, React version. So this is actually nice to call out. Mine doesn't have this. Mine doesn't have a drop down that lets me show the differences as the API changes. So older versions of React, this will look different than React 16.4. We're past 16.9 now, so you can see what that. It's somewhere. I don't even know where to actually do it, but this will serve our purpose. When a component is mounted, the constructor is called. We won't worry about these lifecycle methods because they are a bit more advanced and we're trying to keep things a bit simpler for ourselves. So let's just say that after the constructor gets called, there are other lifecycle methods that get called, but if we don't use them, it's irrelevant. And we move on to the render, which is the critical part of any component. So mounting, constructor, render, and then after the render is complete, we get a component did mount callback in our component. And that's going to look like this right here. If we declare this function, React will call it at that point in time for that component. Okay. So that's the mounting phase. They've also got they've broken this down into render, pre-commit, and commit. And commit is actually when the DOM has actually been applied. So we've gone from the virtual DOM to the actual. We're putting this into the browser DOM, so it looks the way the user expects it to. Okay. For unmounting, we have a component will unmount. It's not component did unmount because by then it's gone. There is a component will unmount that'll be called, and it's like a deconstructor. In other languages, you might have a deconstructor that'll get called before the class is removed or cleaned up, and that's sort of what this is for. Is before this component goes away, maybe we want to do some things with it. So we could do those things inside of the component will unmount. But again, the only method that's required in any component is render. So if you don't have a component will unmount, it won't get called. And then we've got the update cycle. So here, whenever a component changes, the component did update call will be triggered. So I click the button, or I set my initial state here to 0. And I render the first thing, which is 0, and then a button that says increment. I click on the increment button, which is going to be able to find this because I used an arrow function here. So I've bound this context correctly in one of my 5 different ways. It's able to access this .state.count, take 0, add 1 to it, set that as the new state. The component then re-renders. So React at that point gets the set state call. It knows to re-render this component. When this component re-renders, we start its updating lifecycle. New state is the reason for the trigger for the change. It's going to go down. Okay, we'll skip these two. We don't really care right now. Should component update is a way for us to prevent rendering if we want to. So this is actually more of a performance consideration than anything. So we'll skip that as well. It renders. Okay. So now we've hit this point where it renders again, and the new value here is 1. And then it calls component did update. So now component did update will get called. It passes in the props from the previous render because we can tell whether or not things changed or not. Here we say, yes, something has changed. Either the props or state changed. We know the component was updated one of 2 ways. If the previous state count is not equal to the current state count that we have, then we know that it was the count that changed. This is actually a replacement. Essentially, we don't need to do this anymore in a lot of cases. You're not going to see this type of a check because of our dependency array. Does this check for us? It checks to see if the previous value is the same as the new value before running a side effect, which is kind of cool. So we don't actually do a lot of this explicit previous to current checks in React anymore. Is component did update similar to use effect? I don't want us to think about it that way, but it is the closest we have, I guess. So, but use effect is called after every render. It doesn't matter if it's a mount or not. Or it doesn't matter if it's the first one or not. And that's the main difference, is that component did update will not be called on mount, whereas use effect is called after every render. I don't care if it's a mount or not, right? So I'm being very specific in describing that and saying my use effect hook is called after every render. My component has a component did mount call that's called after it mounts, and it has a component did update call that gets called after it renders. Those are two different things. Let's keep those separate. But yes, it's similar in that we do a lot of the same types of side effect handling with those two different APIs. Cool? I'm being very careful, I guess. That maybe you feel like I'm being too careful, but you can't be too careful with this point. So, open up to questions. We'll talk quickly about the app we're going to build. We'll take a break, and then we'll come back and write the code. Sound good? Okay. So I'll spend another little while. Any questions? Any questions? Looks like we're pretty good. I can come back to it. Thank you for the live questions, Rashab, even though I haven't been super on it. You've motivated me to be looking at that. I just got to get in the habit, right? It's like flossing, just keep doing it. Okay, let's code, right? And that means that I can bring this up, and you can immediately tell me what this means, right? Anyone want to tell me what this means? What does this describe? It's okay if you don't know, because we can actually try and figure it out first. Yeah, exactly. So we've identified that it's a Christmas tree. Thanks, Trevor. Yeah, a Christmas tree of React components. It describes potentially the parent-child relationship between components in a React application. What else do we see on here other than a parent-child relationship? Props, yep. States, thank you. Yeah, great. So WebSockets, yeah. So what I've been trying to do here is create a diagram that roughly describes the architecture of the app we're going to build. Now, I've identified a few things in it. One thing I've identified is which components are going to go into the application. I've also identified which props those components receive. So, actually, this might need to be moved down, but basically, application receives no props. It only has two pieces of state. Whereas room list receives two props from its parent, and it has its own state called rooms. It also happens to have a side effect where it makes an Axios request to fill this list of rooms with the available rooms for the chat. The room itself is passed down 4 different props: a room prop, a socket prop so that it can actually manipulate that socket, the one that exists in the application. The reason the WebSocket exists in the application is so that if this component is mounted and unmounted, we don't lose that connection. We can join and leave the room, but we don't want to lose the connection to the server. We want to be able to leave the room and then join another room and not lose any of that state. So that's why we're keeping the WebSocket here at the application level. And then down here in the room, we'll pass a reference to that socket down as a prop so that we can call this props.socket.send to send messages to our web server ultimately. Okay. This has messages. So every room will have its own messages for the chat. And when we go into the room, we'll do an HTTP request using Axios to get all the current messages. And then when someone types a new message and we receive that on the WebSocket, we'll just add it we'll add it to the list of messages that we have there already locally. Okay. In the room, we have 3 components, and it's either going to be a name component or a message input component. Because once we've decided what our name is, then we can enter messages. So one thing I didn't put here is that this is conditionally rendering either a name or a message. Both of them are passed down props. One of them is passed a prop that lets you set the name. Looks like that's because the application has the name state. So we have to pass from application to room to name, the set name call. It has its own name state down here. And that's because name is going to use input as a controlled component. So this is going to be just what's currently typed into the input field at the time. And then when you hit enter, it's going to call set name, which is going to pass all the way back up and change the name state in the application. And then the same with in message input, where the messages are actually at the room level. So when we type in a message, and it's going to just keep track of the local state here, but when we hit enter on the message box, it's going to pass that message back up to this room component and send the message on the socket, and then update the local state to include that message as well. Okay. And the last thing is a pure component down here that doesn't have any state. It just takes in props, a prop called messages, which is the list being passed from the room down to a component that knows how to render a list of messages. Okay. So I've gone through that. That's the first time I've gone through it with anyone. Any questions about that? Does it seem like a good idea to draw this out? Does anyone think that they could, and of course you could look at your code to do it. I would never suggest not looking at your code to do this. Drawing a diagram similar to this for the interview scheduler. How about your final project? Would you draw a diagram like this for your final project? I would say that you probably don't know what this looks like when you start your project, but as you start to build your project and you keep this live, you keep this as a document that you keep updating as your project changes, you can always just look at it and say, oh, how does the data flow through my application? Now, of course, it's not easy. There's a lot of stuff on here, but I tend to ask students to draw their component diagram when they're struggling to understand how data is passed through their application. And I recommend anyone here, if you go start a new job and that application already exists and you have to learn it, draw a diagram like this, or even take a subtree. This doesn't have to be from the root. I could just focus on just the room component and its children. As long as I know what data it has access to, I can focus just on pieces of a React tree. Okay, so that's my recommendation. I'm going to leave this up right now. So if anyone still wants to look at it, but let's take a small break, come back, and we will. Actually, I want to run the app first. Here, sorry. So I've got web browser running. I've got, say, I'm going to run the socket server as well, and I should be able to connect to it. So here's the app. I'm going to half of that. And I'll grab another one as well because we need another tab for this. That Deno is interesting for sure. Okay. So yeah, so it's pronounced Dino, or I pronounce it Deno, but it's pronounced Dino. I'm trying to correct myself on that. And it's very interesting to me. Better than Node, I think. I think that they have been successful in solving some of the things that they don't like about Node, that some people don't like about Node. I feel like they have a long way to go, and I feel like uh, although Node has a massive amount of packages and infrastructure, um, th- they're working on compatibility across so that Node libraries could be run sort of in a Dino runtime still. So I think that there's going to be. Is it better? No, I don't know. It's hard to say. I wouldn't use it in production today, that's for sure. But I will use it to build a WebSocket server to teach you how to build React apps, and then also you can take a look at TypeScript and 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 Dino and the API, and not have to actually commit to learning it. You just get to look at it, right? So it's kind of a that's why I do things like this, mostly because it's more interesting for me to build this app in Dino than it is in Node because I already know how to build it in Node, and Dino has a slightly different API. So that's why I did it that way. Um, let's check this app out quickly. There are 4 rooms and a leave button. I actually think I can't do anything with that yet. I click on one here. I enter my name. I click on 2 here. I enter my name. If I type a message here, I can see it on my chat, but the other user can't because they're in a different room. But if I switch over to one, then I can see the messages from that person because it just did an Axios request to grab all the messages that existed already. Now it's pre-populated this component with those messages. So now when I say, oh, there you are, now we actually get the message on both because both people are in the same room. Okay. If I switch back to 2, that message goes into that room, not in here. If I switch over 2, we can see it here. So pretty straightforward. If I leave the room, well, I can go back in if I want. All right. Does that all make sense? Okay. So any questions about this before we go? And then when we come back, we'll start building some of the components for this uh, to learn about class-based components. Awesome. See you soon. Okay, Ruben's here. I think everyone's here now. Okay. Okay, let's get started because I do have to finish this at 12 so that I can start mentoring. Unlike last time where I had as much time as you were willing to give me. All right. This is the app we're going to build, and this is where we're going to build it. So I've got my app running right now. I'll just leave the server running. I've got my Webpack dev server going. You might guys. I see. We're still talking about the bonus packs and the money siphon. All right. I can definitely talk about EA and games and stuff outside of the time that we're spending on this. So if anyone wants to talk any other time, just send a message on Slack. I can jump into Discord too. Whatever you want. We'll focus on this now. So before we get started, may as well just kind of look roughly. We have the ability here to look at the built app already. We don't need to think about it as an empty slate. We could kind of look and see some of the structure of this, and then go back and start to write this stuff. So maybe what I'll do first. Ooh, keep doing that. Maybe what I'll do first is git branch live and switch over to a live branch. So any changes I make are not going to affect my master branch. Now, all right. So here's this. This is the application, and based on our diagram, it should have 2 pieces of state and also a side effect of connecting to a WebSocket. So when I look in that here, I can see there's 2 pieces of state. I've set them in the initial state. I like to put all of my state in here so that I know what state exists in this component. So even if I'm going to add new state later on, maybe I'll put the default here, or I definitely will put the default here, make it available, and then it's just a clear description of all the state this component has. One thing I don't like about classes that you'll notice now is that there's no description here about what props this class takes. Whereas if I write this as a function, and I destructure props here, or I say props here, and I destructure, I get an idea in this component what props this has for the most part, let's say. Whereas in the class, there's not really something nice that gives me that sort of self-documenting behavior. So just sort of something I noticed now that I never really paid attention to before. But the idea here is this has state, and then also this WebSocket connection, and it happens when the component did mount lifecycle method is called. So what we get from this is when this component mounts, after that's completed and it's rendered the first time. So first thing happens is it renders out a room list, and if there is a socket already, then it will render a room. Otherwise, it will not do that. So there's conditional rendering here based on whether or not we have the socket or not. So there's a dependency on this component on having a socket. So we make sure that that is available first. So the only thing we see on the first render is actually a room list. Okay. And that will render whatever it renders. It's going to be passed in the state, which is empty string. It's going to be passed in a function that knows how, oh, look what I've done here. Different way to bind. So if we look at this function, join room, This is an instance method. It uses this context. Therefore, I can use a different form of binding if I want. I'm going to show you all the different ways to do it, but choose one. Don't do 5 different ways. Maybe choose 1 or 2 and stick with them. But I'm going to try and show you them all. So here, I'm taking this function, which otherwise would have its context changed when we call this function. Well, because I say bind, and we know this is the correct value inside the render, this creates a bound join room method, which means that when select room gets called, it's actually going to have the correct this context. So instead of us doing, in this situation, instead of us doing the arrow function and doing it this way, we can also bind directly when we pass that function in if we want. Okay. Alternatively, you can also do where we wrap it in an anonymous function, so this context is set correctly there. Okay. I'm going to leave it like this because I like to have a few different examples in here. So what else does it do? Okay, so it makes the WebSocket connection. When we make a WebSocket connection, when we're done with that connection, we do need to clean it up. We should know that about WebSockets. And so for that reason, we'll call close whenever the component unmounts. So this is sort of the cleanup phase of this component. And this is different than the cleanup phase of a use effect, because a use effect cleanup is not just called on unmount. It's also called before the next effect is called. So it gets called potentially after every render, or every time a new use effect is going to be a new effect is going to be triggered. So these are not the same things. This is, even though we're doing the same kind of thing where we create the socket and then we clean it up, it's not the same thing. Slightly different. So I have to think about it differently. But for my component here, when the application loads, I want to make a single WebSocket connection, and when the application gets unloaded, I want to close that connection nicely. Okay. Let's actually get rid of this. So this is actually, I'm going to try and make this a bit easier. I'll make that full screen, and I'll get rid of this other one for now because we only need one current view. So right now, that doesn't work. I didn't pass that function in. But let's get this component working first before we worry about the other ones. Let's make it so that we can load the list of rooms and display them in this component. Then we can worry about all that other WebSocket stuff. Okay. So this room list is going to be rendered here. And that is a component over here, which I'm also going to, I'll actually leave that. I don't want to write this again. I don't think I need to write this in front of you again, right? We're past the JSX part now. We're pretty familiar with that. So I'm going to leave that in, but I will take out, some of this stuff here and re-implement that. Okay. So if I run this now, it's saying attributes. So it's complaining I can't send empty values, but these are the kinds of things that I use just to shut it up for now, because I'm going to replace this with good stuff later on. I just want it to stop complaining. Okay. So now all I have is a list of rooms, but the only button I show is leave because my list of rooms is empty. The initial state is no rooms. So as it maps over an empty array, it returns a new empty array, which gives me an empty array for rooms. And then when I render an empty array, it doesn't render anything. And the only thing that I get is my leave button. Okay. So I want it so that when this component mounts, so when I load the room list for the first time, I will make a request to the API, and I'll show you what that looks like. It's localhost 8080/rooms. This is what comes back to me in my room list API call. It's pretty straightforward, an array of 4 room names. Okay. So I want to set up my component lifecycle method that says that the component is now mounted. We've rendered it the first time. So the first thing that's going to happen is it's going to render this view, exactly what we have now, because the rooms is empty. And then it's going to say that the component is mounted, and then we will do our Axios request to get the rooms. Then when we get back our response, we can grab the data. Oh, that's covering that up. Get out of there. We can cover the data. We can grab the data for it, and we'll rename that just to rooms immediately. And then, how do I actually take this array of rooms, the one that I see that's just this right here? That's what's coming back as data. How do I take this and make it so that I now re-render this component with that new array? Now I'm looking at the chat because I know because there's spread it into the rooms array. Okay. Uh, like that. Okay. So we never just like with other state, we never set directly, right? So if what I would say is, I need to set the state to be that array that I received. So in this case, technically, I don't need to spread it because I'm not creating a new array. Or sorry, I'm not creating. I'm not. The array ends up being the same thing. There's no new addition or edit here. So I actually probably could get away with, well, calling set state. That's what I really need to do. And I need to pass set state the new value that I want, like so. And that can just be the rooms that's coming from here. So it's okay. So this is kind of what it looks like now. When I receive the response, I call this dot set state. The set state will set the room state, which is this value here, to the rooms that were just passed to me from the API. And because we're not modifying that object, it's okay to pass it directly because it's new. It's the one that was created here. We can just keep passing that. No one else is using it. If you want to be super safe, and I recommend, I like super safe. This would be super safe. That would guarantee that you're cloning it. If that's what you want to do. No problem, right? I would say that the code we write looks like this because we use shorthand techniques to try and just make things easier to write. So this is a rooms key with the value of whatever's in the rooms variable. So that's what we're setting as state is this new rooms array that was returned from the API. So now when I go over here and I reload and we look at the inspector, I will load the page and ultimately we'll make this rooms request and we'll get back that array. And then we see the data from that array up here now in our API or in our application. Make sense? Okay, what about, let's do this. Just to make sure we lock it in. This dot state dot rooms. This is what happens when you don't do a lot of where is it? It's just so nice not to have to type this every time in my functions. It's too bad. Yeah, because I just forget it all the time. Okay, so let's try that out. Where is it? Ah, just a couple of console logs taking me that long, really. So here's the output. Go over to the console and we'll see it rendered empty. That was because, well, it called the constructor. We didn't have one. So we didn't get any, we wouldn't put any output in there. Then it called rendered with an empty array. That's why we saw just leave. Then it, oh, that's interesting. Why are we, let's try this again. Sorry, I missed the chat. Okay, why do you call then rooms? Couldn't you just say then rooms or then data? Okay. And then think it's because the access gives you an object. Yeah, you're right. So Rashad, it is because of that. And here, what I really would get back from Axios all the time is response. And so rooms is response.data here. And I can write it this way, and I totally think if you want to, go for it. I can also use destructuring where I take out just the data and rename it to rooms. Here, meaning I can use the shorthand like so. So very similar. Yeah. Okay. Some rooms is not defined. What I do rooms. So we're going to double update here. I'm not quite sure why that is. I won't worry about it too much. Just notice here that we get rendered with the empty list. We get component did mount with the empty list. It does our API request right here. And then we get rendered again with our new the data that was downloaded from the API. So that's going through the life cycle of a mount and an update. That's the mount and then the update. And we can have as many updates as you want, depending on how many times props change or how many times state changes. That's going to decide how many updates happen. But there will only be one mount and there will only be one unmount for the lifetime of a component. Any questions about that? So we're able to now get this data in here. That's good. Okay. So now we got our room list. Now what we need to do is actually show when we choose a room, we want it to change the state here inside of our app to be that room that we selected. So that's what I'm going to do first. I guess what I'll do just to make this easier to see what's going on, is I'll just kind of render this .state.room down here, and then we can see what the value is. And then when it changes, which for room list, it's going to happen whenever we click on a room, we're going to call a choose room button. So in that case here, like I kind of built this already. So let's get rid of that. And let's build this function here called choose room. And this takes in a room and it calls this .props.set, or let's say, I think set room, and takes in that room value. I guess, yeah. I guess I could probably just do this down here. Okay. So for now, I won't bother doing that way. It's hard to know. Should I put it here or should I put it down in the JSX? I mean, I move it if I don't like it. That's my rule. Is if I find that this is not the right place for it later on, I'll just move it and decide that I couldn't have made the right decision because I didn't know enough about what my component was ultimately going to look like, right? So here it'll call this .props.set room, or if we go by our diagram, it should be, yeah, it was set room. It's a function that takes in a room name and then is able to change that there. So we'll now pass that function down to it. We'll say you have a prop set room, and this is going to call the let's say, what happens when we join the room? Oh, we need to set the state. We take in the room. This is the value we take in, and we call this .set state, and we call room, and the value we want is actually just the room being passed into us here. I'll let you look at that for a second. I don't want to jump away from it. I'll let you look at that for a second. Is there anything weird about what I've just done? What do we think will happen to my name when I do this? Is this necessary? Or you haven't seen me do this yet, but I haven't really needed to because I haven't had two keys inside my state yet, right? Okay. So this is going to get confusing for you because you learned the hooks way first, or the way inside hooks first. But the way that React set state was designed is that it will do this merge for you. You don't have to do it yourself. It will do it for you. So simply by changing only the room key, React will take the existing state and only change the room key for us, but keep this existing value for name. So one of the nice things about the old set state API is that it did the merge for you. Now, why is this relevant? Or why doesn't the new why don't our methods currently do this? Whenever we do something like this. So here, if I call set state, I have to take state first, spread it in, and then change room or whatever. Right? This is kind of what it might look like and what we're familiar with. The reason why is because this thing here doesn't require this to be an object, so it doesn't know that it's something that could be merged. This could be just as easily the number one, right? Whereas we would never say set state one because this must be an object that we pass to it. So it can make an assumption that you want to merge here, but with the newer syntax, it's not going to make that assumption for you. That's why you're doing those merges before you set. That's why you're saying whatever. Okay, is that clear to everyone? That the in the classes set state will merge your key into this state object for you. So now we've passed this function down. When it's called down here in the room list, it'll call that function. The reason we pass the current room down, is so that we also know. Let's see, for the room list, we pass the room down so that we know, for example, here, when the room that we're currently that we have selected matches the room we're rendering, we want to show that that button is selected. So that's why we're passing the room to this component as well. So in here, we just apply a style conditionally based on if this is the currently selected room or not. And it gets all of that information because it knows what room it's in, and it has the list of rooms itself that it's rendering. So it has all that in there. All right. So let's see if that actually works. I can bring up my Chrome. Oh, I didn't install. Okay, I'm going to install them now. No, not Chrome. It's React DevTools. All right, my application state currently has name and room to its initial default state. If I click on the to room, it should call the set room button with the word to in it. It should call that set room function with the word to in it. And when it does, I can see here that it changes my state in the application to 2, and it also renders that state out down here because that's what I instructed the component to do right here. Okay, so we're successfully passing the function down just like we do normally. We're calling the set state call when it gets called to change the state which exists at the higher level. Right, we had to make this state up here because the current room must be shared between room list and the room component itself. So we couldn't just keep only the current room down here because it actually is needed here as well. We're passing it down. Okay. So that's the room list. Once a room has been selected, it's going to join it. Now, in order for that to happen, we actually do need a WebSocket connection because, or actually, no, I guess the thing we could do first is just have it load the existing messages and not receive any new messages. So let's start with that. I'm going to go down here and say, I'm going to render the room component, and I need to at least pass it uh, the the current room so that it can go and retrieve the messages for the room that we just entered. Does that make sense? I'm going to do an Axios request, and it's going to get all the existing messages. As long as I know what the current room is, that'll work. Okay. So now when I render this room, chances are things are not going to be very good here. I'm going to just get rid of all the implementation and let's get rid of, well, let's keep that for now. And it should only render the message list, I think. Okay. So if I join one and I look at what it's rendering out the message list now, but the message list has an empty array, so we're not seeing anything. I'm not going to worry about my name right now. I just want to get the list of messages, let's say. So in order to make these messages exist, I have to fake it a little bit. I'm going to say content first, name, or user. What's going to be? I actually didn't really think about the fact that I didn't have messages first. Okay, let's do it this way. I just got to create a user as well because I don't put the user's name right in the message up here. I put a reference to their user object so that they have a name, something like that, and then also do a time. Oh, come on, TypeScript. Oh, room socket. Okay, that's why. So the user needs to know what room they're in. It starts off, I think, null, and then also a socket will say null. Maybe that'll work. I don't know. I haven't tried it this way yet. How do I get the terminal now? There it is. So I'll restart this server and see if that even works. Okay. Set to null. So is that a question as to why I did this, or was it? Okay. Sorry. Sorry for missing that. Yeah. Okay. So now what I need to do is actually check to see if I've got this list, which is going to be messages, and then I put a room at the end of it. So I think it was just room one. No, messages. There we go. So now my / messages question. So I'm putting a query string on the end of onto the end of the URL, so that I tell it which room I want the messages for, and this is the array of messages that I'll get back when I do that. So now if I go into my component again, here the messages array needs to be filled with a through an API call. So I could probably just go over to my room list, hijack exactly what I have here, move it into my message list, let's say, or my my room, and make it load the messages. And I need to put a question mark here, so maybe I'll just change this to template literal. I can say room is equal to. Okay, so now what should I be setting this to? Yeah, the state. So, well, the state, not necessarily. So let's look at this diagram again. When I load my room, how do I know which room I'm currently in? It's the state. Yeah. So rooms ID, name state. So the name state we haven't dealt with yet. The current room is the name of the room we're currently in. It gets passed. It's this dot props dot room. Okay. So up in application, it's this dot state dot room. But because the application passes that room to the room component, which is what we're working in right now, then the room is actually this dot props dot room, and it's the one that exists at the parent level. Right? There's no room state inside this component. Cool. Okay. Yeah. Now, when we get the room, what we're going to back is let's say messages, not rooms. Messages. We'll take those messages and we'll fill them in here. And then I think if we go to our app and we join, no, still not yet. Oh, it's rendering that no matter. Okay, this is what we want to do is we want to make sure that this dot state dot room it exists. Otherwise, we won't render that thing. There's no point, right? If we don't actually have a room selected, there's no point in rendering the room view, let's say. And I'm going to clear the. Okay, see that works better. Okay, so now when I mount the thing, it's not rendering a room yet. We can see that here. The room has no value. When I click on the room and I choose it, then the room now has a value on application. It's 1. That gets passed down to the room itself. So this dot props dot room is 1. And then it finishes rendering. It calls component did mount. It makes an API request, and it gets back the list of messages from the server. Cool. Yeah. Okay. Same thing. Just getting more practice. Okay. But now we actually need a socket connection, because if someone else were to connect and send messages, we would not receive those new messages. We only get the messages that were loaded initially. So, and actually, we're not even changing the messages when we go between rooms, for example. Maybe that's what we should fix next, is make it so that when I go from room 1 to room 2, we don't see this message anymore, because that's a part of room 1. But now I'm in room 2, so this should be empty. So the way that I would do that is I would say we need to actually also not just make this request when we mount the component, but also whenever the component changes. And I have a dependency here on this .props.room. So I want to actually make an API request to Axios for the room messages every time the room changes. Does that make sense? Okay. I got to copy and paste this code, for now at least, into a component did update. And it takes in prev props and prev state, so that I can actually check to see whether or not this is the thing that changed or not. Because what happens if I do this? Oh, component did update. Well, that's not what I meant. This is what I meant. Uh-oh. So, we're familiar with this already. This has happened to us already, I'm sure. I mean, most people have probably seen something like this, an infinite loop in their React app. And really here what we're trying to say is if the prev props dot room does not equal this dot props dot room, in that case, that's when we want to make the request for the new messages. But if it's some other state change, then let's not make, we haven't changed the room. So let's keep the messages we have already. And then when the room changes, then we make the request and update the messages. But you'll notice here, we also do a set state on messages. And this will get skipped, even though or this is if prev state dot messages does not equal this dot state dot messages. That's how we would check to see if the messages changed or not in here. So you'll start to see that in more complicated apps, you'll start to see a lot of this type of code in your component did update because we have to identify what dependencies we care about changes for. So when I run this now and I go in here, it loads it the first time. So I get the list of rooms. I click one, I get my list of messages. It doesn't infinite loop anymore. And I can switch back and forth between these two. And every time I do that, it gets the messages for that room. Right? Okay. It's just a dependency on this prop changing. That's all that matters to this API call. All right. So I said, yeah, let's fix that problem first. Maybe we should set up, right now, if I put in my name, it crashes. Let's fix that. May as well make that work first, because then we can't type messages until we can set our name. So we need to go back to our diagram here and say, oh, we have this name, and set name gets passed down to the room component. Here, when we're in the room, we have two options. If the value of name is truthy, then we will render a section that has the name statically embedded in the document and also a message input field that allows you to type in your message and press enter. If you do not have a names prop, then render the name field that allows you to set the name. And actually, let's get rid of this for now. We don't have the ability to send anything yet, so we'll wait for that. But right now, we can at least change the local state whenever that happens, right? We don't have to tell the server yet, but we can tell the local machine to change. So I'm going to pass this prop down from the application to the room. And when I do that, I also need to probably pass down a set name function. And this is going to be very similar to our set room function, right? I'm just going to do this as an example, but I would probably keep it the same as the other one. I just may as well show you different ways to do it, right? So here, if I decide to make it an instance method instead, I will do this.setState and set the name that way. Now, when I pass this into the callback here, I can pass that in, but I have to be careful of binding. I'll get an issue. I'll get an error if I don't. So I'm going to either bind it, or let's say I'll make this an arrow function to fix that problem. So now change name. I pass in a bound change name function to the room. The room will call it down here whenever the name component, which is actually pretty straightforward. This is just a controlled input. This should be familiar to people. If it's not, definitely review this. So I have some state. Every time the input changes, I modify that state to have the current value, and then the component re-renders with that state again. Once I press enter, then I call the set name with the current value in my state. Okay. So what that looks like is I go into my room, I type in my name, I hit enter, and I get cannot read bind of undefined. So that's this.send message.bind somewhere, probably just my old code. So message input. It's now trying to render this message input component, but the problem is I don't have a send message function. So I'm going to, for now, say that doesn't matter. Try that again, go in here, put my name, hit enter, and it's actually set my name. I can confirm it's part of the state, because if I go to my application up here, I can see that my name is in the state of the application. Okay. And if I type messages, well, it doesn't do anything right now because I just put that null function in there. Okay. So when I actually type a function or type a message in, I want it to call that send message. So that's where I'll create it now. I'll create it in this component. This is the room component that I'm still in. Send message. And I'm just going to take in a new message this way. That's what I expect to get from the send message function here. If I look at message input, it just calls it directly with the message value right there. Okay, and then it actually resets it. It sets it back to empty string. So when I hit enter, it sends the value and then it resets it back to empty string for me. I'll pass that send message in now. And don't need to go too far with it. Let's just make sure this works first. This is a recommendation for everyone. Really what we want to do is add this message to this array, to the end of this array. But first what we want to do is make sure that this message is correct and that it gets passed into this function correctly. So that's why I'm going to do this first. I'm just going to make sure when I come in here, I put my name in and I look at the console output. I see that message show up here. So that is now hooked up. That the action that is passed down is hooked up correctly, and we're getting that data back up here at the room level where we need it. And the reason we need it there is because the send message. The reason we need it there is because that's where the messages actually exist, but it gets called down here. So here we'll concatenate to the end of this array, or at least just push onto it. Messages, and this is where we'll do our spread. Okay. So I'm saying I want to take the existing messages. This will actually be wrong. That's just me being used to previous, right? So this .state.messages is our existing array. We take that array, spread it into a new array, and add the message onto the end of it. So we're doing a push on top of a new array. We set the state to that. It will re-render and show us the new message now right here. Oh, no, we got a problem. Invalid time value. Okay, so we've got this issue now where we need to actually add the time as well. We need to say, we can't just add the message. We have to add this constructed already the way that our list of messages expects. So let's fix that up. I'm going to show you in here. What does it actually look like? I made a mistake, didn't I? I took this and added it to my array. I took the new message and added it to my array, but I needed to create an object that contained that inside of it. So that was my mistake. I need to create a new array. And the other thing I expect in here is the user's name. And I have access to that, don't I? It's right here. Looks good. I know there's lots going on here. It's complicated. It's designed to be complicated because you don't have to build this. You just have to see it, right? So it's going to be a reference for you. What you build today is not going to be as complicated as what I've built here. Fair? Okay. All right. So now I'm changing only the local state, but I need to send that message to the server because right now the server, which I can actually get the status for anytime I want. If I go up here, I can get the store. This is currently what's in the server. I'm not sending anything to the server. This was my default stuff. So I'm going to go back into my server code here. I'm going to remove this and start with an empty server and make it so that I can start to add messages to this data store that's on the server that's keeping track of all of everyone's messages in one place. And so the only reason I'm doing that is just so that I don't have any default messages anymore. So I look here. This is the base store for my server. And it's not the same as my React state necessarily. I grab some of that stuff and I put it into my React state. Okay, so now what I need to do is make it so that when I type this message, it actually sends it to the server as well. And for that, I'll need a WebSocket connection. I'm going to go into my application here, and I'm going to start to set up component did mount. So when the component mounts, I will connect to the WebSocket server. And when the component unmounts, I will disconnect from the WebSocket server. And I know it's weird that I'm doing it this way because I know the API, but it's this.socket. I'm not actually creating the socket as state because it doesn't need to change. So I've just created an instance variable here called socket, and I'll create a new WebSocket. And I'm going to use an environment variable here called React App WebSocket URL. So I'll go in here. And so now I should be able to go and see when I load this app up, it should make the connection to the WebSocket server. Does anyone know how to make sure that that's happening? Does anyone know how to debug that part of it? Okay, well, let's do this. Let's go into our network tab. And under the network tab, there's actually a WebSockets filter. And when I load this up, we can see that a connection is made successfully to that endpoint, that /WebSocket or /WS endpoint. I'm now successfully connected to it. It doesn't do anything, but this is how I check. I check inside of my network tools under WS for WebSockets. And I can see I have another one here. What do you think this one's for? What do we think this socket's for that I'm connected to? When I go into my browser, or when I go into my code right here, you're noticing I'm never actually reloading the browser. I go in here, I make a change, I hit save, and I go to my browser and I just let it change. I let it update, and everyone else has been doing that as well, right? It's pretty incredible. Don't ever work not like that. What's the point, right? Okay, so how does the browser know when to refresh? The Webpack dev server is running a socket connection. When we load our app, we connect to that socket connection. When Webpack dev server has new data for the browser to load, it tells it through a WebSocket message. So that's how we get live reload as well. And that's why you'll see these two different sockets here. The one that I'm using for my application and the one that I'm using for my live reload environment. Okay. This socket, I'm not sending messages here necessarily. That all happens within the room itself. The only reason I'm building the socket here is because I don't want it to open and close every time I change, or every time I unmount this room component. So therefore, I'm going to go down here. I'm going to actually pass the room component my socket, so that inside of the room I can say this.props.socket, and then do this.props.socket.send inside that other component, and use this connection that's passed down to it. So in here, what I want to do, whenever I send a message, I don't want to just update the local storage. I also want to this.props.socket.send JSON.stringify. And now this is where I have to remember what the message is, but I think it's just well, I can actually go look it up. I'm looking for a new message. Let's just see. Oh, it's in here. When I receive a message from the client, it's going to be either join room, leave room, set name, or new message. So the one I want to do right now is actually, well, we'll try this first. We'll do the new message first, but it won't work unless we actually have a room joined, I don't think. Because we need to join a room so the message gets added to that room. But for now, let's just try and see what this looks like. So the type of the message has to be new message. And again, this is not something you need to really learn because this is specifically about the server that I'm working with. But here I'm going to say the type that I want to send is new message. And the actual content I want to send here, wrong one, here, I need a message prop, or a message property on that on that data that we're sending down. So I also need, yeah, that's what I need right here is this message. And that happens to be just the string that was sent in here. So that's all I'm sending to the server. We're going to see it in the output when I do that. When I go in here and I connect to the room and I hit Carl, and I type in a message, hello, I should now see, I get the WebSocket message. So I'm actually receiving that WebSocket message on the server. The new message, that's what we're seeing right here, new message. That's new message. And then the value of message was hello. That's what I typed in. But here it says, shouldn't add a message if not in a room. So I have a little bit of error handling in this app here where it says, I shouldn't add a message if you're not in a room. And it just checks to make sure that the user's in a room first. Okay, so let's put them in a room before we send a message and fix that error. The way we put them in a room is when I need to take this code here and I need to send a WebSocket message whenever you mount the component, let's say. I need to join a room, maybe something like that. So every time I mount the component, I will make the Axios request to get all the latest messages, and then I will join the room as well to make sure that any new messages I create get added to that room specifically. Let's see if that works. When I load this up and I go down here and I type in my name and oops, no, that's not my name, whatever. Type that, and now I look and I see now it's joined the room number 1, and then when I sent the message, it actually didn't give me that error anymore. And if I go look at the state of my application here in the store, I can see that's a bunch of me refreshing, by the way, because every time I refresh the browser, I do get a new socket ID. So don't worry about that. Really, I only have one currently active user. That's this one right here. We're not setting the name yet, so that's why it still says anonymous. But overall, this is the message that I've now sent to the user, to the server. And if I come back here now, I reload and I join, it will say that message that I put in there before. It's now persisted on the server. Okay. We're getting close. I just want to do a few more things to make this to finish this thing off. Okay, so that's great. If I go over here, that's interesting, right? So that put that message in that first room. I went to the second room. I typed a message and I hit enter. But right now it put it into this room instead. Why is that? So let me show you again. I went into my app. I went to this room. I typed a message, hello. Okay, that makes sense. I'm in room 1. So now when I look at my state, I have that hello message. And then I change over to room 2 and I say, what's up? And here I add it locally to this room. But when I look at the actual state of the server, it got added to room number 1. Why is that? We're not clear. So we don't technically unmount right now. When I switch between these two rooms, I don't technically unmount because I don't need to. All I'm doing is changing the state of what room I'm in right now. If I look at the component here, I can see that in my application, when I click between these two, there, 1 and 2 and 3. But what we're not getting is a message to the server to say that we're also changing rooms. So the server still thinks this user is in room 1, even though the user thinks they're in room 2. And that's because nothing has told the client to join room 2 instead. So every time the room changes, we also want to join that room. I've just copied this code from here. Look what I've done. This is a mess. This is the problem with lifecycle methods. This code is the same thing in both of these. because I want to do it when I mount the component, and I want to do it every time I update as well. What I like about useEffect is it doesn't care about mounting, does it? So I don't have to separate those things out. I can say, I want you to update when this prop changes. Whenever room changes, do these side effects. That's what we get out of it. So you're going to see this a lot. And this is, again, one of the great benefits. This is what makes this is why when I talk about it originally, uh, complex components become hard to understand. It's because we start to end up with a situation like this where we've got just so much duplicated code. And of course, I could get into a situation where I say, um, join room, and I put that code in here, and then I call join room when I mount, and I call join room whenever it changes. Okay, so I've reduced some of the duplication, sure, but there's still duplication here, right? I still have to think about the fact that this is when it starts and this is when it updates. So I think this is a good example now of how of some of those things that they were trying to fix, and some of the stuff the React team didn't want to continue to do in their applications was a lot of this sort of managing of the life cycle. So now when we go in here, room 1, oh, that's me. Okay, room 1 says, and now when I see the server knew when I sent that message that I was on the other room now, so that's why it's adding it to the correct place. So it's not just when I mount that I get the messages and I join the room. It's also every time, or sorry, yeah, it's every time the room changes as well. Cool. Then I do have to clean up. Like if I, for example, leave, which doesn't do anything. Okay, I won't get too far into it. But basically, if I leave, what I want to do is set my room to empty string. That's what I would do. Is I would call set room empty string whenever I click on the leave button. Actually, may as well do that. Room list. When I click, so is it disabled or not? This button here is only disabled when I am not in a room. So this dot props dot room is equal to empty string. That means I'm not in a room, so I will disable this button. I will also make it so that when we click on that button, it calls this dot set props dot set room with empty string. Okay? So that's kind of how the leave functionality is going to work. So when I go in, I can go into room 1. I can click on leave and leave, I think. And now if I look here at my state, I think it's, I'll try that. Okay, 1. That's just a socket output that's making that big. Okay, so let's see. Why is this? Start room. That's okay. Oh, wait a second. So I want to make sure that that socket is created first, because I know that the component did mount potentially could happen um, before that socket is done, right? Because it'll mount. Well, it shouldn't happen until there's a room, actually. So that's probably not going to change anything. But I do want to be a bit safer there. I want to say that because there's this dependency on the socket, I don't want to render this component until there's a socket. I don't want to render it till there's a socket. I don't want to render it till there's a room. Both those things have to be true for this component to be shown. So we'll leave that in there, I think. Okay, so then the last thing I want to kind of think about before we break off here is how do we handle it so that um, when the user sends a message and the server then rebroadcasts that message to everyone, that the people that get that new message broadcast to them, that they also add that message to their list of of messages. So this is going to be inside of the room down here. We're going to say that when the component mounts, this props.socket.on message. Okay, this is going to be our event handler for the sockets. Is this unfamiliar to anyone? What I've just done here? I've taken the socket and I've added an event handler for on message. Okay. Whenever I receive a message, well, let's just look at it right now. And I think for this, I'm going to need to have two clients connected. Okay. So I'll connect one, put their name in. I'll connect another one. And I think I just want to look at this inspector here. Oh, I have to fix that as well. I'll do that. So I'll look in the console. Now when I type a message in here, I expect to see I got a message event right here. So this is the data that's being passed in over the WebSocket connection. I've got new message comes from Carl. And now there's two people connected. We get a broadcast to one client. How many clients are connected? Two clients connected. How many clients do we broadcast to? Yeah, I'd say clients minus one is the real answer, right? Because I don't want to rebroadcast that message back to the person who sent it. There's no point. So what I've done is I've set it up so that the rebroadcast will only go out to everyone who didn't send the message to them, to the server. And that means that the person who sent the message will not have their state updated at the same as well. Okay, so it just avoids a second call for that. But that's why this says broadcast one client, is because even though we have two clients connected, it's only going to the person who didn't send the message. So here, when we receive a message, we want to, if we can look at this actually, this is a object. It contains a key called data. Data has our string, which is JSON. I'm passing JSON back and forth over the WebSockets. Why am I passing JSON over the WebSocket? Could it be that we can only pass strings over the WebSocket? We can't pass objects and stuff. We can pass strings, and so we can encode our data in as JSON and then parse it when we get back. So I'll take that data, and I'm going to say if data.type or is equal to new message. Do we have the data we want now? We'll double check that. Bring it up. Test it out. And now say, hey. And this is what I've just console logged out, is an object that got received from the WebSocket server that has content, a time. Where'd that time come from? The server added it. So I only added the time when I created the message locally, let's say, right? It's kind of a cheat, but in this case, when it went to the server added the time and then sent it to everyone with the time on it already. It also has a type and then the name of the user who created it. It looks like I'm not setting the name right now on when I actually change my name, so that's why it's not changing from anonymous. But the code in the actual final project has that in there. So if you're curious about that, feel free to go and look. It's not much different than what we've done already. So it would actually even give someone an opportunity to kind of see something different, right? So we've got this object. What I want to do is now add this to actually just the content, the time, and the user to my array of messages. Or it's data dot content. We also need the user and the time. Okay, let's try that. So refresh. Join is 1. Join is 2. When I go over here and I say, hey, Susan. Oops. Susan sees that message come from anonymous. But that's just because I haven't set that name when I actually do it. So I think all I need to do for that is so here when we set the name, we'll also send a message to the socket. Now I'm actually having to copy and paste this quite a bit. So what I would probably do at this point is a tiny abstraction call where we'll say uh, send takes in data and it just does all this extra JSON stringify and all that kind of stuff. So this is going to be our data. And so now it would just be this dot send data. And we can kind of use that instead within our component. It's kind of a nicer way to do it. And just leave the JSON, the prop socket, the JSON stringify stuff, leave that to be abstracted within here and kind of commonized there. So now here we say this dot send with type being set name, I think. I'll just double check that. Set name, and it needs a name property. Cool. And then I will also update the call in here that does, so this should just be this dot send. With just the object I want to send. So that's looking better. This is component will unmount. My bad. And let's just make this happen right now. We'll send the type of leave room whenever you unmount this component so that it sets the room back to null for that user. Okay. Run that. I'll join up. I'll say Carl. And join this. I'll say Susan. And then I'll say hey from Susan. And we have the name properly working now. Hey, Susan. And that user is now showing up here. So that pretty much brings us, I think, to that was the last kind of thing I wanted to talk about. I'll go and look at the code quickly and just make sure I didn't miss anything in the project itself. I think we went over a little bit, but the time was not super bad. Let's see. Pretty much what we did. Most complicated one is this room component here. But that looks pretty close to what we had as well. Every time we change the component, we update the room info. So I put this comment in here under send message, tell the remote server store to update, and then update the local store as well. That's the 2 different steps that we're taking here. I think, yeah, these 2 different steps here. So we set our local storage, and then we tell the server that we want to update so that everyone else gets that change as well. When they get that message, it comes here as the on message event, and this is where we actually do the set state for them there. So I think we've covered it. I know that's a lot. Code looks wet. Yeah, good. Well, I mean, it's legacy React. What do you expect? Nothing I can do about it except use hooks now. Okay. Was this valuable? We feel good about classes now? Okay. Today's activities are pretty much just step-by-step tutorials just to get you exposed to the syntax. I didn't put a lot of effort into them. I put more effort into this, I think. I'm kidding. But you'll see It's not a super complicated mini project that you'll build. It's over 3 activities, and it uses, I think, even fewer of the things that we did. Although I think I tried to hit these 3 life cycle methods at least. Okay. How likely is it we'll end up working on this form of React after school? Most likely, if you join a company, they will have class-based components still. If they have a project that's more than a year old, uh, it's just how many they'll have will be determined by the team's own uh, desire to to clean up things or not. So, if it was my team and let's say I'd been working on React for a couple of years on a project and I had a bunch of components that were built as classes, and then hooks come along. I'm definitely not going to ignore hooks, but I'm definitely not going to go through and change every single class-based component to use a function now instead. What I would start to do is create my new components using hooks because React doesn't care. And then if I had older areas that needed to be that I need to do major refactors or major new features, I would make a decision at that point if it made sense to re-implement any of it using hooks or not, and only if it was going to make adding those other new features easier on me. So it really is a decision. I wouldn't go and change every class-based component to be a function component because you don't really get anything for that. It's only in terms of when you start to maintain and stuff later on. So most companies, I think, are transitioning from what they have now to ultimately a fully hooks based. When I started doing all of this, I talked to development managers at React meetups and asked them, "Do you think that we should teach class components anymore, or have you switched completely to hooks?" And every one of them said all of our new components are built using hooks. So hey, thank you. Uh, Dope lecture. Thank you. No better compliment.